At what point or points in the interval 0 included, 2 pi not included, is the tangent line horizontal for g of x equals cosine of x plus sine of x? A horizontal line has a slope of 0. The slope of the tangent line is the derivative, so we're going to find where the derivative equals to 0. Our function g of x is made up of two terms that are combined by addition, so that our derivative g prime of x can be done in each term independently. The derivative of cosine is negative sine, and then you add the results together. Derivative of sine is cosine. There's the slope of the tangent line at any x coordinate on the graph. We want to find where it's a horizontal tangent or have a slope of 0, so we're going to set that equal to 0 and solve for all the x's, and keep only those that are in the 0 to 2 pi interval with 0 included and 2 pi not included because of the round bracket. So we need to find where negative sine plus cosine equals to 0, or negative sine equals to, subtract the cosine the other side, negative cosine. Cancel the negatives out, and it's equivalent to finding where sine equals to cosine. Then maybe you can think on the unit circle where that's occurring. That is always possible. It turns out that'll be at pi over 4, and then again at 5 pi over 4 where they're both negative. But if you don't see that right away, another option we have is let's divide both sides by cosine. I will put this over cosine, I will put this over cosine, and this side turns into tangent, and this side turns into a 1. So it's equivalent to also finding, well, where is the tangent equal to a positive 1 specifically, and that's going to happen at pi over 4, and then over in the third quadrant, 5 pi over 4. These are the x-coordinates. We're going to want to find the corresponding y-coordinates to each of these. So let's start with the x equals pi over 4. Our y-coordinate will be found by plugging that pi over 4 in to the function g of x. So g of pi over 4, which is cosine of pi over 4 plus sine of pi over 4. The cosine of pi over 4 is root 2 over 2. The sine of pi over 4 is also root 2 over 2. We can add these together to give us 2 root 2 over 2, and the 2's can cancel, so root 2. And that means we have x-coordinate of pi over 4, y-coordinate of root 2. There's one location. The other one is the x-coordinate of 5 pi over 4. 5 pi over 4 is in the third quadrant. The y-coordinate will be found by plugging that 5 pi over 4 into the function, and we will have cosine of 5 pi over 4 and sine of 5 pi over 4. And since 5 pi over 4 is in the third quadrant on the unit circle, these are going to both be negative root 2 over 2. Combine them, we get negative 2 root 2 over 2. 2's can cancel, and we have negative root 2. And here's the other point in the 0 to 2 pi interval, where we will have a horizontal tangent line, x-coordinate comma the y-coordinate. Now if you extend the interval to be all real numbers, there's an infinite number of places where this will happen, but here's the 2 within the 0 to 2 pi range. 2 points where we have a horizontal tangent line.